There are two basic systems to measure angles that we're going to be looking at in this course. And when we measure angles, we're measuring the amount of rotation from the initial side to the terminal side of the angle. And there are two ways that we're going to look at measuring angles, degrees and radians. And degrees you're probably familiar with. There's 360 degrees in a circle, so 1 degree equals 1/360th of a circle, or 1/360th of a full rotation. Now, nobody really knows for sure where this 360 degrees comes from. One of the most likely culprits for discovering this 360 degree or implementing this is astronomers from watching the sky, or sailors from watching the sky, and knowing that this earthly rotation happens every 365 days. Well, 365 is not quite a neat number to work with, but 360 is real close, and that's a nice number to work with. There's a lot of numbers that can divide into 360. So that's probably where that system is coming from. Now, before we start talking about radians, I also want to mention that there is another type of way of measuring angles called gradians. And in this system, a right angle is 100 units. Right? And when we're measuring a right angle in degrees, we say that it's 90 degrees. Well, 90, again, is not a number that's real nice to work with, but 100 is. So what is interesting about both of those systems of measuring angles is that those numbers just seem sort of arbitrary. It's just like, those are nice, neat numbers to work with. Let's use those numbers. Well, there's a better way to measure angles when we're working with a lot of higher order math, and that's called radians. Now, first of all, before we talk about radians, we need to recall the definition of a central angle. It's an angle whose vertex is at the center of the circle. And 1 radian is the measure of the central angle of a circle that intercepts an arc length that's equal to the radius of the circle. So you can see in my picture, this radius length is r, and the length of this arc is also r. So the angle measure that makes that true is 1 radian. So what is interesting about this way of measuring angles is that this definition of this angle measure is coming from the angle and the circle itself. It's not any abstract numbers that's imposed on this system. It's a ratio that's inherently within the geometry that we start with. The radian measure of any central angle of a circle is the ratio of the length of the intercepted arc to the length of the radius. Now that we have this formula, theta equals S over R, we can look at this diagram and see this relationship between arc length and radius. So if my arc length and radius are both the same, then I have R over R, which equals 1. So 1 radian is when this arc length is equal to the radius. And we're going to see a little bit later that 1 radian is approximately 57 degrees. This formula is one of the first formulas that we're talking about. It is on your reference sheet. I want to talk just a little bit about that reference sheet for a few seconds. The reference sheet is going to be found in the Document Sharing Center in my math lab. And the main reference sheet that you're going to be using throughout this course is 2 pages long. Normally, if we're in class, I will give you a paper copy that's printed front and back. Please pay attention to your directions with your study guides for your test, because sometimes you're allowed to use reference sheets and sometimes you're not. And sometimes you're allowed to use a certain reference sheet. Sometimes you're allowed to use calculators and sometimes you're not. So please pay attention to what it is that you're allowed to use. But anytime that you're going to be asked to use that formula, you will have a reference sheet with that formula there for you. In my first example, the directions say to determine the angle measure. And here's our formula. Theta equals S over R. Theta, this angle measure right here, theta, is going to be 250 centimeters over 120 centimeters. So that simplifies to 25 over 12. Notice that my units cancel out. Radian measures do not really have units. It is a ratio. So normally you don't have any units written outside of this number, but every once in a while you will see this sometimes written with radians beside it, just to emphasize the fact that we are talking about radian measure. Problem 2, find the radian measure of the central angle of a circle of radius 120 inches that intercepts an arc length S of 90 inches. There's my formula. And there's where I filled in my unknowns, and then when I stick this into the calculator and simplify, I get 3/4. Right, now this next thing may seem kind of basic, but I think it's something that's worth repeating. If you have an angle, let's say that's 30 degrees, or we can measure it in radians, it doesn't matter which of these circles that I'm looking at with this radius. All of these angles are going to be 30-degree angles. This red line here can keep going out forever if we wanted to, and keep getting circles bigger and bigger and bigger. And that angle measure is still 30 degrees. So the radian measure is the same for all of those angles as well. And because the radian measure is a ratio, the longer this radius is, the longer that arc length has to be in order for that ratio to be consistent throughout those concentric circles.